Hi, welcome guys. So I already made this video before, but some people say that the video quality, quality is not good. So that's let me just remade this video. So the goal is to prove this s to the 4 plus y to the 4 equals z squared has no non-trivial solution. There's no non-trivial solutions. Okay, so what do we mean by non-trivial? Means that okay, so it should be non-trivial integer solution. So the idea, the non-trivial means that x times x, y, and z should all be the integer, and they are both all of these should their product should be non-zero. So that means x non-zero, y non-zero, z non-zero. Okay, and this is the obviously it's a special case. Fermat's last theorem for n equals to 4. Okay. Okay, so now let's give the idea. Okay, so the proof is very lengthy and very easy to make trouble. So let's see the first part. Okay, so the first thing is I should say that I can assume that both are greater than 0, and there are no common divisor, right? If there are common divisor, then I can divide everything, right? So they are coprime. And your easy mathematics, your easy idea will tell you that we can assume x is odd, y is even, z is odd. Okay, so easy. Okay, and by the Pythagoras theorem, tell you that okay. So let's see. There is this a and b. They are both integer. Positive integer such that x squared equals a squared minus b squared, and the y squared is 2ab, and the z squared is a squared plus b squared. Okay, so we collect everything here. Okay, notice that right, this guy is odd, right? So from here, then you can get another equation called b squared plus x squared equals a squared, right? And then you get y squared equals to 2ab, and then z squared equals to a squared plus b squared. Okay. So the key idea is that I should reshuffle something, right? And hope to get the same equation here, so that we can use the infinite descendant. So the idea is that suppose there's an integer solution here, then by your construction, then you will construct another positive integer solution. But the problem is that the integer cannot be infinite small, right? So that will give us a proof. Okay, so let's see here, right? So here tell you that you should use a Pythagoras theorem again, right? So it's a very boring, but you just keep doing. Oh, remember that now x is odd, right? X is odd. So which tell you that let's see. So we tell you that there should be a u and v, right? Such that x is a u squared minus v squared, right? Because x is odd, right? And the b is what? So from here that b is even, right? This is even, this is odd. The reason is that b should now here should be written as 2uv, right? And your a should be u squared plus v squared, right? So a is odd. Oh, so let's make a table to make sure everyone understand the who is odd, who is even. Okay, so odd and even. So now I assume that at the beginning I say x is odd, right? Y is even, z is odd. So x and z, y, right? And from here that I say a is odd, b is even. So and from here I say the u is even, u is odd, right? V is even. Okay. And let's see where we missed something. Oh, sure, okay, right. So this is a table that it might help, it might not, right? But it's not important. Okay, so now we get here and here, right? Okay, so what's going on, right? How can we finish our proof? How can we construct another solution? Okay, so from here that we know that y squared is 2ab, right? But you see, let's see. So y is even, right? And a is odd, right? So that means the r squared part, right? So let's see, y can be written as odd times even, right? and then you square, you get the odd square times even square, right? But you already know that who is odd, right? So who is odd, who is even, right? So so from this you know that the a should a is odd, right? So a should eat all the odd part. Okay, so there's a chance that a should eat some odd part, right? So a should be eat some odd part, right? So a should be written as a tilde square, which is some odd number, right? And then your b, right? Your b should eat all the rest even part, right? So if a is a tilde square, then the b should be let's say 2k squared. Right, the reason is odd, so that y squared can be written as 2 times a tilde squared 2k squared, which is 4a tilde squared k squared. So y is 2a tilde k. Right, so y is a square, right? Okay, so that means we got something called b is 2k tilde good k squared, and I mean I don't care 2k squared, k is even or odd, right? So we can put in here, right? So you get the k squared equals to uv. And the same reason that this is odd, right? This is even, right? So u should be another u squared, big capital U, which capital U should be odd, right? And then your v should be small v should be another capital V squared, which this v should be even, right? So, but you have these two, right? But you have these two, right? So you get the a tilde squared equals to small u squared, which is a capital U to the fourth. Small v squared, which is capital V squared, right? So capital V squared to the fourth. So you get another solution, right? Which is I should say what, the descendant of original one, right? So from here that you know there is no solution. Okay, so this is a proof idea which you just not very difficult. You just get your Pythagorean theorem twice and you argue about number theory. Okay, so hope I remade this video will make this the old school problem become clear. See you guys.